let's just see whether there is any real life application or real life use of coordinate geometry or not. So obviously yes, there is a real life application of this coordinate geometry. For an instance, if we are talking about the airplane navigation, then coordinate geometry helps us to find out or to navigate any particular airplane. So coordinate geometry do have such an importance in our real life. Furthermore, if we are talking about the astrophysics, that is the motion of Earth and Sun, this is all about the coordinate geometry. Furthermore, in the medical aid, we also have used the coordinate geometry in a very vast manner. As we can see over here in an MRI report, we can see that there is an x-axis, there is a y-axis, and these two axes are really playing an important role in this MRI report. So this is all about the real life application of the coordinate geometry. Now let's just further move on and talk about the Cartesian system again. As we can see that in the Cartesian system, we do have two axes that are perpendicular to each other. So let's just talk about the horizontal axis first. As we can see over here, we do have some numbers as 0, 1, 2, 3 and so goes on, and -1, -2, -3 and so goes on. So let us suppose now we are calling this horizontal line or the horizontal axis as x dash. Let us suppose we are taking it as x dash, but before that we are just talking about their 1 unit distance. As we all are aware that the distance in between all these points are nothing but 1 unit distance. We all are aware about this situation, that the numbers that are lying on a number line are always at a 1 unit distance. But furthermore, if we are talking about this particular line or this particular horizontal line, we do know that this O point is nothing but called as the origin, and now let us suppose we are calling them as x dash. Always remember to call the horizontal line, which is also called as the x-axis, as nothing but x dash. So we are taking the horizontal line or the x-axis as nothing but x dash, and in the similar manner we are taking the vertical line. We are taking the vertical line having the origin within as nothing but y dash, as y dash. Now let us suppose we are taking both of them in a graph, then we can see them all together as this. So x dash, y dash, this is nothing but our two axes which are perpendicular to each other. And always remember, we always call the x-axis as nothing but x dash. The positive, or we can say that the numbers which are on the positive side, we call them as x, and we call it as x dash as the numbers over here are negative. Similarly, the numbers on the y-axis, on the positive side, we have 1, 2, 3, 4, we call it as y, and similarly we call this section as nothing but y dash. So always remember, in the Cartesian system, whenever we will take the two axes, that is the x-axis and y-axis, we call the x-axis as nothing but x dash and y-axis as nothing but y dash, and wherever they intersect each other, this point O is nothing but called as origin. This is nothing but called as origin. So this is about the Cartesian system again, or the important concept that definitely help us to locate the position of a point in a particular plane. So let us suppose further we are talking about being positive or negative. As we can see over here that this region starting from 0 towards this is nothing but positive, so we call it as a positive x-axis. We also have seen that the numbers that are on the right hand side of 0 on the number line, are all positive. So as we can see over here, the numbers from 0 over here is nothing but positive. So that is why this is called as the positive x-axis, because the numbers are positive. And in the similar manner, this is nothing but called as the negative x-axis. But before that, we are talking about being the positive y-axis. As we can see over here, the numbers over here are positive, so we are calling them as positive y-axis. This is called as the positive y-axis. Similarly, this is called as the negative x-axis. Similarly, this is nothing but called as the negative y-axis. So always remember, in a Cartesian system, whenever we have two axes, that is x-axis, that is y-axis, we call the x-axis as xx dash, we call the y-axis as yy dash. And in the x-axis, we have two regions. We have two regions separated by zero within. Region 1 in which we have the positive numbers, and we call this as a positive x-axis. We call this as a negative x-axis because the numbers over here are negative. We call this as a positive y-axis because the numbers are positive, and we call this as nothing but a negative y-axis because the numbers over here are nothing but negative. So this is all about the Cartesian system, in which we have positive numbers, in which we have negative numbers, and we call the axes on the basis of being the number as positive or negative. So I hope this is all clear to you. So let's just move on further. And let's just talk about quadrants. What are quadrants? As we all know about the introductory part, which is done by me before, that what are quadrants? We do know that there are 4 quadrants, and how they are formed, as we do know that the two axes actually separated any particular plane into 4 sections, and those 4 sections, let us suppose we are talking about this. So these 4 sections, that is 1, 2, 3 and 4, they are nothing but called as quadrants. They are called as quadrants, and we always have to take the quadrants in an anti-clockwise direction. Always remember to take them in an anti-clockwise direction. This is the quadrant 1, that one is the quadrant 2, third quadrant and the fourth quadrant. So always remember, whenever two axes is actually a plural word of axis. Axis means a single axis, that is x-axis or y-axis, and axis is a plural word of axis. So I am talking about the axes because I am talking about the x as well as y-axis. So whenever the x-axis, or we can say that whenever we will draw the axes in a particular plane, then they will divide the plane into the 4 sections, and those 4 sections are called as quadrants. And we always have to take the quadrants. In an anti-clockwise direction. So these are nothing but called as the quadrants. We do have a special note which is related with the quadrants, that the axes are called as coordinate axes. We can also call the axes, that is xx dash and yy dash, as nothing but the coordinate axes. So always remember, the axes can also be called as nothing but the coordinate axes. Moreover, we can call this situation, or in which we have the x-axis and y-axis Cartesian system, we call this particular system as nothing but a Cartesian plane. We can also call it as a coordinate plane, or we can also call it as an xy plane. So always remember, whenever we will draw the two axes in any plane, then we can call it as a Cartesian plane, we can call it as a coordinate plane, or we can call it as an xy plane. So we can call such a plane in 3 manners. We can call it as a Cartesian plane, a coordinate plane, or an xy plane. So these are the 2 notes that you have to remember. The first one is the axes are called as the coordinate axes, and further Furthermore, if we are drawing the two axes in any plane, then we can call them as the Cartesian plane. We can also call them as a coordinate plane, or we can also call them as nothing but XY plane. So this is all about the quadrants. Now let's just move on further and let's just talk about the position of this point. So let us suppose we have this point on a graph and we just wanted to find out the location of this point on the graph. So let me just draw the axes all together. So we do know that we have an x-axis over here, we have a y-axis over here, and we just wanted to find out the location of this point. So how we can find the location of this point? So first of all, we can see that this point P is actually at a 3-unit distance, from the y-axis or from the origin, we can say, and it is 2 units above the x-axis. As we can see over here, if we are talking about its distance from the x-axis, from the y-axis, so we can say that the distance of this point P, from the y-axis is actually 3 units. This is 3 units, as we can see over here. This is at 3 units, and its distance from the x-axis is nothing but 2 units. As we can see over here, the distance of this point P is nothing but 2 units. So let's just mark it first. As we can see, its distance from the x-axis, its distance from the y-axis. So how we can locate this particular point? As we can see over here, its distance from the x-axis, from the y-axis is actually 3 units and 2 units. So we can mark it as 3, 2. We can mark it as 3, 2. So what is 3, 2? So what is actually 3, 2? So let us suppose I'm writing it over here that the position of this point, is actually 3, 2. This is actually 3, 2. So this is something unique. This is something different. We do not know about that, how we have written this 3, 2. This 3, 2 is actually called as a coordinate of the point. This is called as the coordinate of a point. So what is the coordinate of a point? So if abscissa is x, so there is something which is interesting, that what is abscissa? What is the meaning of abscissa? So first of all, let me just tell you the meaning of this abscissa. What is this abscissa? Abscissa means the distance of a point from the y-axis. Abscissa is actually the distance of a point from the y-axis. Abscissa means the distance of a point from the y-axis, and there is something different again, or a new word again, which is nothing but an ordinate. Ordinate. What is ordinate? What is ordinate? Ordinate means the distance of a point from the x-axis, So this is all about abscissa and ordinate. So after taking abscissa and ordinate all together in a different manner, we call it as nothing but a coordinate of a point. So as we can see over here, the definition of a coordinate of a point says, if abscissa is x, means the distance of a point from the y-axis is x, ordinate is y, means the distance of a point from the x-axis is y, then x, y, within a bracket is called as the coordinate of the point. So let us suppose we are talking about this particular point P again. So let's just see its distance from the x-axis, from the y-axis. So first of all, we can see that from the y-axis, its distance is this one. From the y-axis, this distance is actually actually 3 units. As we can see over here, this is nothing but a 3 unit distance from 0 to 3. It is 3 unit distance. So this distance will also be of 3 units. So it means this distance, which is nothing but called as abscissa, that is a distance of a point from the y-axis. This is a 3 unit distance. This is a 3 unit distance, and we can see over here that the point's distance from the x-axis is actually 2 units. We can see over here that it is a 2 unit distance. So definitely, if this is a 2 unit distance, then this will also be a 2 unit distance because they are drawn parallel to each other, and thus this is a 2 unit distance. So this is nothing but our ordinate, and this is nothing but our abscissa. Abscissa means the distance of the point from the y-axis. Ordinate means the distance of the point from the x-axis. So when these two, abscissa and the ordinate, written together under a bracket in the formation of x comma y. So x over here is nothing but 3 because the abscissa is called as x. So x is 3 and y is 2 because the ordinate is 2. Y is 2. So when we write both of these in the formation of x comma y, means in the formation of 3 comma 2. So this is nothing but called as the coordinate of a point, which actually specifies the position of a point in a plane. So this is all about the coordinate of a point. So always remember, whenever we just wanted to find out the location of the point in any particular plane, then we have to look out for the coordinate of the point. And in the coordinate of the point, we have two things, abscissa and the ordinate. We just have to look out for the abscissa. We just have to look out for the ordinate. Abscissa means the distance of a point from the y-axis. Ordinate means the distance of a point from the x-axis. We have to write both of these in a bracket all together. So x comma y is nothing but called as the coordinate of the point.